Hello students, this is your Mahesh sir. This time I brought to you a video on JEE Mains paper solution which was held on 27th of Jan 2024. We will solve 10 questions, there are 30 questions, we will solve 10 and consider this as one part. Now, in this video I tried to explain in detail most of the answers. So try to take the full advantage of it, watch till the end, okay, and watch it in details and try to understand every bit of the answers. Yeah? Let's start. So here's a one question on combination. The first one is on combination. So what we do is here in this case we use one of the properties of combination, and the property is here, right here. Here I have tick mark. This is a property. NCR is equal to n upon r, n minus 1 CR minus 1. So we will use this property and try to solve the question here in this part. Okay, so we will replace that property. I'll write the property here. So NCR is equal to n upon r, n minus 1 CR minus 1, right? This is the property. So we will apply it to this particular part here, this particular part of the answer. Why we do it, you'll come to know. Let me write it here. I will write it as n minus 1 CR is equal to k square minus 8 time. Instead of writing n and r plus 1 here, I will write this. So I will replace n with n and r with r plus 1. R with r plus 1 using the same property. So I am writing it as n upon r plus 1. I am replacing r with r plus 1. So this becomes n is same C r. This is r plus 1, right? R plus 1 minus 1. So 1 1 minus from here, no, 1 1 minus from n and r. So that's what I am doing. So this face of this will change. See what happens. This becomes n minus 1 CR is equal to, you have k square minus 8 n upon r plus 1. This will be n minus 1 CR, right? R, right? So this is same as this side and this side. Both sides are same. So ultimately we can cancel. You can cancel. So what do you get? You get k square minus 8 is equal to r plus 1 upon n. Yeah, we are at particular safe level. No, now we can play the game. You can see the solution where k lies. Okay, the trick is what we can find out. If you observe on the right hand side, okay, these are numbers. Using combination we get numbers only. No, we use numbers for combination. So this can never be 0. This has to be always a positive number. So this is always greater than 0. So we get certain judgment from here. We get to know that k minus, or I'll write here, k square minus 8 is greater than 0. Now we can solve the solution for k. So we say k square minus 2 root 2 the whole square is greater than 0. Now here we can use wavy curve method to find a solution for k. What is wavy curve method? Just find here. So we have k minus 2 root 2 into k plus 2 root 2 is greater than 0. Okay, let's use wavy curve method. We get the two critical points, minus 2 root 2 and plus 2 root 2. Here see, minus 2 root 2, this is 2 root 2. And it has to be positive. The solution has to be positive. So you put any value higher than 2 root 2, you will find the answer is going to be positive. So this side is positive. Any value lesser than minus 2 root 2, you will find the answer is still positive. Put it and see. You put something like, minus 4 root 2. So this will be minus 4 root 2 will be minus 6 root 2, right? Minus 6 root 2, and this is also going to be negative. So the answer is ultimately going to be positive. So here is positive. Anything in between, say put 0 and see, put k equal to 0. You will see the answer is minus into plus is minus. So you are getting this type of wave, right? And this has to be negative, solution has to be negative. So solution lies in this range, this side. Okay, it is beyond minus 2 root 2 and beyond plus 2 root 2. So we have the solution for k as it's minus infinity to minus 2 root 2 union plus 2 root 2 to plus infinity. So we have got one particular solution. Now k has to be on either side. Okay, let's see where else k lies. We'll see where it is. Now from here, from the look of it, look at this equation in particular. You will realize that this number which is below c has to be lesser than n or equal to n. This number cannot exceed n, right? That number cannot exceed n. So you have r plus 1 is always less or equal to n. It cannot be greater than this. So we have here, see, r plus 1 upon n is less than equal to 1. So we got another judgment from this, and that is you have r plus 1 upon n which is less than equal to 1. That means k square minus 8 is less than equal to 1. So you have k square minus 8 is less than equal to 1. Yeah, correct? So get 1 on this side. So you have k square minus 8 or minus 9 is less than equal to 0. You are having a similar situation where you can say k minus 3 into k plus 3 is less than equal to 0, right? So again go for wavy curve. We have two critical points, that is minus 3 and plus 3. Yeah, if you play the same game, you will come to know it is going to be the same way where this is positive, this is negative. Similar. Right? And now we want a negative answer. So k has to lie between minus 3 and plus 3. Right? So we have another solution for k, which is, and both are included, right? Less than or equal to. So you are putting it in this interval. Here is the solution, right? We have got 1 and 2 solution. Let us combine the two solutions. See where k lies. So we have an entire line with minus 3 on one side, plus 3 on another side. You have minus 2 root 2 here, you have 2 root 2 here. Let's see where the solution lies. This statement shows that the solution is here, and minus 2 root 2 is not included. So round circle, empty circle here this side, this is also another circle, and this is the range of k. This is the range where the k lies. Solution of k. And here minus 3 and 3 are included, right? So it lies from here to here. Sorry, where is 3? Here. This one. So k has to lie in between, combining both the two solutions. K has to lie either in this or in this, right? This is what k lies where k is greater than minus 3, and it is greater than equal to minus 3 and less than minus 2 root 2. Here k is less than or equal to 3 and greater than 2 root 2. Let's see where the solution is. So where the solution is, it is the first one, minus 2 root 2. So the answer is this, right? We have used this formula to get the answer. Yes. Next, let's see here. This is a 3D geometry. It's very simple one. If you know basic formulas of 3D geometry, you will be able to do this. What they said is distance of this point from this particular line and along another line is to be found out, which is to be found out, right? Let's get a line. Let's get a line first. Let's find a nice line here. So we have a line, okay, and we are telling the distance of this. Here let us say these are the Cartesian coordinates of the point, which is 7, minus 2 and 11, okay. These are the coordinates of the points, and the line equation also they are given. So they said this is the equation of the line upon 6, y minus 4 upon 0. Don't worry about this 0 because zeros are possible. All the direction ratios can be 0, so not a problem. So z minus 8 upon 3, right? So what we want is, okay, they have given another line because this distance is along another line. So they have actually given these direction ratios of the other line. So we have this line, okay, and because it is matching to this, the other line, see here, this could be anywhere, but it is along this line, parallel one. So do they match? The direction ratios has to be of this, and the points are here, the Cartesian points. So we are writing in the Cartesian form using this, combining these two. What we write? You have the equation of required line in Cartesian form. You know what is x minus x1 upon a, because it is parallel, no? So we are copying ABC is equal to y minus y1 upon b is equal to z minus z1 upon this. Sorry, this z looks like 2, no? Upon c. Yeah, this we got. Now we got the equation of the line. It's very simple. We got equation of two lines. We just have to see the intersecting point. Once you know this point, you can directly find the distance by using distance formula, right? So we have got intersection we'll use parametric form of Cartesian, okay? So we will write in this as a here We will write the points in a parametric form. So that no need of writing, but still I tell you, say call it as lambda. This you call it as mu. But I will show you by solving this way. So you get x equal to 2 lambda plus 7, y equal to minus 3 lambda minus 2, and z equal to 6 lambda plus 11. You get here. You get x equal to 2 lambda plus 7, y equal to minus 3 lambda minus 2, and z is equal to 6 lambda plus 11, right? So what we do is very simple. We can actually replace these values of x here and y here, right, and z here, and just see whether we can find a value of lambda. Once you know lambda, we can get to know what is x, y, and z, and that is our coordinates, the meeting point of these two lines. Obviously, this is perpendicular, no? The distance has to be the shortest distance. So let's see over here what you get here. So let's replace x with 2 lambda plus 7, 2 lambda plus 7 minus 6, okay, upon 1 is equal to y is what? Minus 3 lambda minus 2, minus 3 lambda minus 2 minus 4 upon 0. Actually, no need of going further. No need of going further. We don't need, because these two equations directly gives us the value of lambda. See, this becomes 0. We get here minus 3 lambda is equal to 6, so lambda is equal to minus 2. Right? No, minus 3 lambda is equal to 6, so lambda is minus 2. You got lambda. Let's see what is x. So x gives us what? Minus 2, 4, 7 minus 4, 3. Yeah. Y is minus 2, so this is 6. This is minus 2, this is 6. 6 minus this is 4, right? And lambda is minus 2, so this is 11 minus 12 is minus 1. So we are getting 3, 4, minus 1. So we got a coordinates here, 3, 4, minus 1. Yeah, we got a coordinates. Now it's very simple. It's very simple. They said the distance. Let's find the distance here. Distance. By using distance. 3 minus 4, 3 is 4 square, 16. We are finding distance. Okay, this is distance. We are finding the distance. This is what is asked. Right. So 16 here plus 4 minus 4, plus 2. 4, 16. Sorry. This is 4, 3 minus 4, minus 4. 4 plus 2 is 6. 36. Sorry. 36 plus 11 plus 1, that's 12, 144. Right, you got this? Okay, let's find what is the distance. So distance is equal to square root of, let's see, 6 plus 4, 10 plus is 6, end number must be 6, whose square is 6. This one, this one, this one, this one. Looks like this. The answer is 6, this is 9 and 1. The answer is 14. You got answer. We had a doubt, so we got answer. Let's go for the next one. Okay, let's go for the next one. This is very interesting. This is a differential equation. We can do it very nicely, but what we will do is we'll split it into parts. We'll divide and see how the equation works. See here, this at t, x is given, at t, y is given, and this is the equation that is given. And they said when t is equal to 0, x is 2. When t is equal to 0, y is 1. Okay. So we will solve in parts. We'll solve up to here. Let's see, we'll solve up to here. So using variable separable method, we get what? dx by dt is equal to minus ax, right? And we get dy by dt is equal to minus by. Yeah? All variables on one side, right? So let's integrate both. Sorry, so we have not done the variable. No, we just wrote this here. This becomes what? So I'll write it again. It's equal to minus ax. We have not done the variable methods, so we'll just do the variable separable method. Here dx by x is equal to minus a dt. Here dy by y is equal to minus b dt. Yeah? Now we kept all the variables on the other side, so we just integrate both sides. Yeah, a and b are constant, so we integrate both sides. So this is minus b integral of dt. So what do you get here? This is ln x is equal to minus a t. Here you get ln y is equal to minus b t. Very nice. Yeah, fine. Okay. They have told us that at t is 0, x is 2, and at t equal to 0, y is 1. So let's see what we get. So that will give us c. Okay, there is c here. No? That is c here. That gives us c. So let's put t equal to 0. So ln 2 is equal to c, and here you get ln 1 is equal to c. This is 0, no? T is 0. So we get C. So this you put here, we get ln x minus ln 2 is equal to minus 80. And here you get ln y minus ln 1 is equal to minus b80. So using the logarithm formula, we get ln x by 2 is equal to minus 80. And you get ln y by 2, y by 1, sorry, y is equal to minus b80. Yeah, so we are at very safe place. Looks like it is, we are close to the answer. Let's see. Not close to, we are a little bit far. There is a long journey here. Let's see here. We convert this logarithmic form into exponential form. So this becomes e raised to minus 80. So you get e raised to minus 80 is equal to x by 2. And here we say e raised to minus bt is equal to y. Yes, okay, fine. So this gives us x is equal to 2 e raised to minus 80. And this gives y is equal to e raised to minus bt. Yes. We got x and y. X is minus 2 e raised to minus et and y is e raised to minus bt, right? So, okay, now let's go to agla padao. This is over. Let's go to the next part. Next part here. At t1, 3y is equal to 2x. Okay, at t equal to 1, 3y is equal to 2x. So let's put t equal to 1 here. Let's see what happens. So when t is equal to 1, at t equal to 1, 3 times e raised to minus b is equal to 2 times 2 e raised to minus a. X is 2 e raised to minus 80, right? So 3 times e raised to minus b is, okay, right? So e we take here, so we get e raised to a minus b, correct? No, minus a goes down, on top becomes plus, is equal to 4 by 3. We get something, okay? Let's say 1, okay. Now let us go to next part. They said here, something else they said. Let's see what they said. They said at t, at t, x and y are equal. So, both are equal. Both are equal. So, you say that 2 e raised to minus 80 is same as e raised to minus bt. Right? Right? So, again we take a that side, we say a raised to minus e raised to a minus b times t. So that I'll write here. So this becomes e raised to a minus b times t is equal to 2 remains, no? Got it? 2 remains. That's okay, fine. So this is our second equation. Now if you watch closely in the first equation, what do you get? In the first equation, you have got e raised to a minus b as 4 upon 3. So replace here. Does it become 4 upon 3? The whole raised to 2 is equal to t is equal to 2. Yes, we replaced, no, we replaced here. So this is equal to 2. Now coming back to logarithmic form from exponential form, that becomes log of, or rather ln 2 to the base 4 upon 3 is t, right? Ln 2 to the base 4 upon 3 is t. That's what they asked. They asked the values of t, value of t here. They ask what is t, ln 2 to the base 4 upon 3 is 3. Right? So that gives us the answer nicely. So just take this screenshot, make sure you understand this concept well. Okay, let's go next. Third became fourth one, yeah. We did this, so let's go for the fourth one. Okay, this is also very nice. This says that A and B with the orthocenter. You know what are orthocenter? The point where the altitudes of the triangle meet. Any triangle, altitudes of the triangle meet is called as orthocenter. They have told to find the orthocenter, and that coordinates of orthocenter have to be put in A and B. They have taken us long cut. They could have easily told A and B is what and then put. But then they said something. Okay, let's find what is orthocenter. For that, first we have to draw a very nice triangle. So let's draw a nice triangle first. Let's draw a triangle, and then they have given the coordinates of the triangle, and that is, let's say this is A, this is B, and this is C. A is 1, 2, 2, 3, 3, 1. So I'll call this 1, 2, 2, 3, and this is 3, 1. That's 1, 2, 2, 3, 3, 1. Right. Now you know what you have to do to find orthocenter. The coordinates are there. This is the point where the altitude of this, and let's say we want only 2 altitudes. No, we don't have to take trouble of finding all 3. We're not required. We only want an intersection point. That's it. How do we get the equation of this and this so that you can join the equation and find what is A and B, right? So you get a equation by using point slope form, right? You can get a slope from here. What is the slope of BC? You don't know, multiplication of the slope is equal to -1 when the lines are perpendicular. So the slope is what? So I'll write here. Okay, I'll write here. M of BC. That's y2 minus y1 minus 2. y2 minus y1 upon 3 upon 2. That's 1. That's that. So M of BC is -1. So this is 1 by 2. Slope of this is -2. So this is 1 by 2. Right? Same way, slope of AC we'll find. M of AC is what? y2 minus y1, say 2 minus 1. So I call it 1 upon -2. Right? 1 upon -2. So the slope of this line, I call it, say, D and E. Slope of BE is 2. Yes, -2 and 2. Yeah, fine. I'm sure you know this. Now we got a slope. We find the equation of both. Let's see. No equation of AD. For AD, we'll find the equation that is y minus y1, that's equal to y minus 2. I'll write properly. Y minus 2 is equal to half times x minus 1. Yes. Y minus y2 is m times x minus x1. So this becomes 2y minus 4 is equal to x minus 1. So that gives x minus 2y is equal to -3. You get the first equation. Let's go to the second one. The second of AC, we got AD, right? So we got BE. Now equation of BE. B is what? Y minus 3 is equal to 2 times x minus 2. Yeah. So we have y minus 3 is equal to 2x minus 4. So 2x minus y is equal to 4 minus 3 is 1. Right? Y minus 2, yeah, fine. 2x minus, this is the second equation. Okay, we want a solution, so let's add this up. So this is 2x minus 4y is equal to -6. Add up, minus, subtract it, plus. So you get, cancel it out, you get 3 is equal to 3y is equal to 7. So y is equal to 7 by 3. So you got equation, comma 7 by 3. Let's see what the first fill in the blanks is. Let's see what it is. So put it in somewhere here. So you get x is equal to 2y minus 3. That's equal to 14, right? X is 2y minus 3. So 14 upon -3. That's equal to 14 minus 9. That is 5 upon 3. Right? That is x equal to. So you get x equal to 5 by 3. Right. So we are halfway. We got A and B. Fine. This is my A and this is B. Set those limits to this integration. Right? You can take a screenshot. I'll move to the next page. Okay. So we know A is 5 by 3 and B is 7 by 3. Let's work on this. Now the equation I1 is given. Let's not touch I2. Let's see what happens with I1. So I1 is given as, I1 is what? Integral from 5 by 3 to 7 by 3. X is what? X sine 4x minus x squared times dx. Now here we can use property called as King's property. You know what is King's property, right? What is King's property? This is a to b f of x is equal to a to b f of a plus b minus x dx. That's the King's property. We apply directly here. So we get I1 is equal to 5 by 3 to 7 by 3. 5 by 3 plus 7 by 3 is 12 upon 3 is 4. 4 minus x into sine of 4 times 4 minus x minus 4 minus x the whole square dx. Right? Yes, we apply this property, we get this. Now let's see what happens. So this one is I1 becomes integral of 5 upon 3, 7 by 3, 4 minus x times, if you solve this, this is going to be, see, 16 minus 4x minus of 16 minus 8x, 8 minus 4 is 4. Ultimately, you are going to end at this point. You are going to get the same answer. You solve it and you will come to know it is the same thing. You solve it, you are getting back to this. Right? So we know that this and this are somewhat matching. Let's see what happens. Let's see what happens next. So we add both I1 plus I1. So we say 2 adding the 2. Say 2I1 is equal to. So 2I1 will be, now when you add this becomes 4 minus x plus x. So it's gone, 4 is gone, then we take it outside, anyway it's constant, so we take it outside. This is same, so this will be integral by 5 by 3, 7 by 3 sine of 4x minus x square dx. Now if you watch closely, your I2 is same as this, your I2 is matching to this. So we are finally at what? We are at what? We are at 2I1 is equal to what? 4 times I2. See, look at this I2. Is the face of I2 here and I2. This is same. This one. This particular part of the integration. Same as this. So we have I1 by I2 is equal to 2. And that solves our problem because 36 times 2 is 72. Right? So that's the answer. Right? Okay. You can take the screenshot. Let's go further. Okay. Here. Fifth one. Right? We are at fifth. Right? Okay, we are at fifth. Yeah, fine. This one is very simple. This one is very, very simple. Now what it says is, if A denotes the sum of all the coefficients, how do you get the sum of these coefficients? Just add the coefficients. No. The shortcut method is to put x equal to 1. You get a coefficient. If you want to find the coefficients of any binomial form, binomial equations, any multinomial equations, just put x equal to 1, you get the answer. So when you put x equal to 1, I'll write here. Put x equal to 1 in A. So, A. So you get A. What do you get? A is equal to what? 11 minus 3, 8 raised to n, right? 8 raised to n. And B will be equal to what? 2 raised to n. Now you alter this. 2 cube raised to n, that's equal to 2 raised to n cube, which is nothing but b cube. So you have a relation A is equal to b cube. This is the answer. Very, very simple, no? Yeah. Okay. Nothing much to say about this, so let's go further. Let's see the sixth one. Yeah, this is also an AP question. Also AP, but okay, very simple thing about this is a simple AP is given, and they have given this 25th term, and this AP is up to 37 term. And they said the number of common terms. So let's construct this AP properly. So the first, I'll call this the first AP as A. So let's call the first AP. It is from 4, 9, so you know what is CD and all, no? 4, 9, 14, 10. What is the 25th term? A25 is equal to 4 plus 24 times 5. Right? And that is equal to 12 tens are 120. 24 5 is 12 10. 120 plus 4 is 124. Right? B. You have B what? 3, 6, 9 going up to A37. Now what is A37? A37 is equal to 3 plus 3 times, right? 3 times 36. Yeah. Again, 18 into 6, 108 plus 3. That's equal to 111. So I'll write this is equal to 111. This is your 24th term and this is your 37th term. Now look at this. What it says is the common terms in this progression. So here A, we know common difference is equal to 5. Here common difference is equal to 3. So we have the first term of this combination of the two. The first term is 9. The first common term is 9. The first common term is 9. We don't know the ending, but at least we know the first term of this AP. So common AP of AB. Okay, so we can say common AP of AB is starting with 9, and you know this, the LCM of the two will give you the common difference of the combination of the ACs, and there is 15. So 15 plus 9 is 24, 39 and so on. Now the tricky part is we have to know the number of common terms. Basically they are asking us n is what, but how do we know the last term? How do you know the last term? can that last term be it has to be lesser than 11, 111. It cannot be, no, because the common thing will not remain beyond 111. So it has to be lesser than 111. So that last an is going to be less than 111, right? It has to be less than. So let's find an. So we have an is equal to 9 plus 15 times n minus 1. Sorry, we don't know, no. A plus n minus 1 times 15, which we know is going to be less than 111. It might see that number with this particular thing may not be exactly 111. It can be 110 or 8 or anything below that. So we will not get n as an integer. Probably we'll get, we don't know. So let's see what we get. So this will be 9 plus 15n minus 15 is less than 11. So this is 6. So 15n is equal to, 117. So we have n is equal to 117 upon 15. And that answer comes to 7.8. So we know that this doesn't exist. 111 anyway is not there. But it is not beyond that 7.8. It has to be lesser, right? So this has to be 7 only. The number of terms, the last term is going to be at 7th place. So the answer is here. Yeah? Okay, I'm sure you understood this. Let's go for the next. Okay, here is this one. Okay. This is of parabola. Okay, from the center of the cell. Okay, it's fine. Okay, is this square? You have to find the shortest distance between the parabola. Okay, now you know this is right opening parabola. Also, you know what is A? You know what is A from here? So you have this parabola. This is 1, 0. A is 1, no? 1, 0. Now you tell me, if I draw any circle here, and if I want to find the shortest distance between this, can this be shortest? Can this be shortest? Can this be shortest? Can this be shortest? Which is the shortest distance? Okay. The point is, this particular distance from here to here is longer. Only this distance is shorter. Only from the vertex to the focus distance is always shorter. So obviously, this circle has to lie on the, this has to lie on the normal of this. Okay, fine. I made a mistake. Select. This has to lie on the normal of the parabola. It has to lie. There is no other choice. Only that distance is shortest because this distance is the shortest for the circle to go. Right? All other distances are longer distance. Fine. We got this judgment. Now let us see from the center. And this is a circle. You know the center of this circle. This is x square plus y square plus 2gx plus 2fy plus c equal to 0. So 2g is minus 2. So g is minus 2. So h is opposite of g, that is 2. So you have the equation as 2, comma, you have the coordinates of the center of the circle as, again, 2f is minus 8, f is minus 8, so k is 8. You must know this, k is 8, okay. Now what they said is, you have to find a distance. In fact, you have to find the distance between this and this. You got one point. What about this point? Okay, for that, can we find the equation of this normal? Yes, we have this. The equation of normal in the parametric form is what? Here, for this, it is y plus tx equal to 280 minus 80 cube. Okay, we know what is 80. So first write parametric form. In parametric form, what? 280 commas 80 square. What I wrote? 80 square comma 280. Okay. You know what is A is 1 and A is 1. So this is t square comma 2t's. Anyway, we don't need this. Let's write the equation. Equation of normal is equal to here y. Yes, it's y plus tx is equal to here. Y is equal to. So I'll write here. Y is equal to minus tx plus 280 plus 80 cube. You know what is A? A is 1. So this is minus tx plus 2t. Here t is 1, right? A is 1 plus 2t plus A is 1, right? Plus t cube. Okay, y. Now we want to know the value of t. How will we get the point otherwise? We want to know the value of t here. This is 8t square comma 2 we want to know now what is t. So this is t square plus 2t. I will write it again. Sorry. I spoiled it here. Come on, this is t square comma 2t. I don't know just now. So this is t square comma 2t. We don't know what is t. If we know what is t, we can get the point here. We can get this point. We can know what is t because we know the point lying on this form, on this normal, and that is 2 and 8. So replace now x as 2 and y as 8. So we have here 8 is equal to minus 2t plus 2t plus t cube. Oh, we got t cube is 3, so that means t is equal to 2. T cube is equal to 8, so t is equal to 2. We got 2. So the point are 4 comma 4. T square plus 2t. This is 4 comma 4. I'm sure you understood this. Okay. So we finally got from t, using the parametric form of writing the coordinates, we got to know the form, the t value, and the t value we replace here. Now it's very easy. You can find the distance form here. 4 minus 2 is 4, minus 2 square is 4, and this will be 16 plus 16, that's equal to root of 20. But they have not asked, they said d square. Okay, they didn't ask d, so they said d square. So your answer for d square is 20. The choice is third. Yeah, very simple. You just have to know the basics of the different equations of parabola. Okay, let's go further here. Now this one tells about the shortest distance between this line and this line is 6 upon 5. Okay, you know the formula for shortest distance. What is the formula for shortest distance? I have not written over here, but I will tell you what is the formula. That is A2 minus A1 times B1 cross B2 dot T, B1 cross B2 upon B1 cross B2 ka modulus. Right? This is the formula, and this is nothing but 6 upon root 5. Correct? No, this is nothing but the distance, shortest distance, they already told is 6 upon root 5. Okay, so let's find A2 minus A1. Let's find A2 minus A1. Let's call this is A2 and this is A1. So this will be 2 comma 2. Where is that first one? This is the first one, no? 2 minus 1, that is I cap. 2 minus 1, that is I cap. 4 minus 2 plus 2 j cap. And minus 5 plus 3. Minus 5 plus 3, that's minus 2 cap. We got A2 minus A1, right? 2, 4, 2 and minus 5 plus 3, that's minus 2 k cap, right? Fine. So this is our A2 minus A1. Let's see what is B1 cross B2. Well, say, what is B1? B1 is here. 1, 2, minus 3, right? So you have, sorry, what I did here? A2 minus A1 is this, no? Lambda, I wrote wrong, sorry. It is y minus 4, no, I got confused, no, A is this. So y minus 4 I cap plus minus 1 minus 1 minus 1, that's equal to j cap. So there is no j cap here, there is no j cap. Minus 2 plus 0, that's minus 2 k cap, minus 2 k cap. This is my A2 minus A1. A2 minus A1. Y minus 4 minus 1 0 2, that's all, plus 2, sorry, plus 2. 2 minus 0, that's k cap. That's our A2 minus A1. Let's see what is B1. B1 is what? B1 is 1, 2 minus 3. So that is I cap minus 2 j cap plus 2 j cap minus 3 k cap. And B2 is 2, 4 minus 5. 2 I cap plus 4 j cap minus 5 k cap. 2, 4 minus 1. 2, 4 minus 5. Sorry, minus 5, correct. So we find the cross product of B1 and B2. So here we have I, j and k. 1, 2 minus 3. 2, 4 minus 5. And B1 cross B2. So what is cross product? Let's write here first. So the cross product will be minus 10 plus 12. 12 minus 10 is, that is equal to 2 I cap. Right? No. Minus, that's minus 10 plus 12, 2 I cap. Minus 5 plus 6. 6 minus 5 is 1. That is J cap. That's, let me check, minus 5 plus 6, yeah, that's correct, no, minus J cap, plus, that is K, no, 4 minus 4 is gone, there is no here, 2 I cap minus J cap only is the, my B1 cross B2, right. So we got this, we need to get this. This is anyway, it's very easy, so 4 minus plus 1, root of 5. So we replace it here. Let's find a dot product of this, where is that, this one, and this one, a2 minus a1 ka and this one dot product. So let's find distance is equal to, in the modulus we are writing 2 I cap into y. Okay, that is 2 into y minus 4, 2 into y minus 4. Okay, plus there is no I here, sorry, there is no j here, j here, so this is 0, so 0, and there is no k here, so rest all is gone. There is no j and k, no, here there is no k, here there is no j, so that is 0, 0, 0, so no use. Let's find a modulus, and we know it is root 5, and this is equal to 6 by root 5, so we have little bit match partly, correct, no? So this will be 2y minus 8 is equal to either plus 6 or 2y minus 8 is equal to minus 6, because it is modulus. So modulus means 6 can have plus and minus values, right? So, and they have said what? Find a sum of all the possible values of lambda. So we will add lambda after getting what lambda is for each equation. So here we have what? Y is equal to 7, and here you have y is equal to 8 minus 6 is 2, 1. Here you have y 7, this side y is 1, and ultimately the addition of this, the addition is what? 8, which is my second option. So that solves our question number 8. I am sure you understood this. You can again check if you want to. You can just pause and see the video. Let's see the next one. This is a very simple integration, and looking at it, you know it, you have to rationalize. There is no other choice you can find. So we will find this here, 0 to 1 upon, I'll rationalize it, okay. So 3 plus x minus root of 1 plus x upon, I'll square it, this becomes what? 3 plus x minus 1 minus x, that is 2. After rationalizing, you get this. So let's take it aside. So you have 1 upon 2 integral of 0 to 1 root of 3 plus x minus 1 by 2 integral of 0 to 1 root of 1 plus x. We'll solve separately. It is always better and safer to solve separately. Tension becomes less. So let's find I1. I1 is equal to this, then this, here goes 2 by 3, then here goes this, yeah. Let us see. इसके बाद 1 upon, this is gone, no, 1 upon 3. This becomes 1, that is 4 raised to 3 by 2 minus, this is 0, no, so 3 raised to 3 by 2. Yeah, correct. Okay, let's see what happens here next. Okay, we can go further on this. This becomes what? 8 minus 3 root 3. Get, we got this? Yeah. Let's see what is I2. I2 is what? I2 is here. So 1 by 2, we get this, and this 2 by 3 in there, 1 plus x raised to 3 by 2. 0 to 1. This is gone, you get 1 by 3. There is nothing much to say, you just go on doing. Slowly, steadily you will do. This is 2 raised to 3 by 2 minus 0, 1, everything is 1. Okay, it's minus 1 only, no? Yes? Simple integration, nothing much to talk about, just an integration. Okay, Then this is what? I1 minus I2. You solve what is I1 minus I2. Find. I1 minus I2 is equal to, here 8 upon 3 minus 3 root 3 upon 3, that is minus root 3, okay, minus root 3, and minus 2, this is 2 root 2, right? I didn't write this, 2 root 2. 2 root 2 upon 3 plus 1 by 3. Correct? No, this is 2 root 2 upon 3 plus 1 by 3. Minus no, so this becomes plus 1 by 3. So you have here 9 by 3, that is 3. This we will write first because they said root 2 first. No, here root 2 first. So we will write root 2 first. So this becomes minus 2 by 3 root 2 and then minus root 3. Yeah. So match, you will get A is equal to what? A is equal to 3, B is equal to minus 2 by 3 and C is equal to minus 1. Right? And you have to solve for ABC, 2A plus 3B minus 4C. 2A plus 3B minus 4C. 2A plus 3B, that is 6 plus 3B minus 2 plus 4. 10 minus 2 is 8. Right? Correct? No? This is 6 2A. Correct? 6 3B minus 2. Yes, correct. So this is your answer. You have got this answer. Right. Okay. So here we have the last question. Okay. The 10th question. What it says here, S is one particular set where you have 10 elements, right? And then M is a set of all subsets. Basically, M is a power set of all these sets. Okay. So you know how many will be there because there are 10 elements, 1024 elements will be there in the power set. But that is of not our interest. So let us see what is next. It says whether this relation is satisfying here. If this relation is satisfying, then is it reflexive? Is it symmetric? Basically, it has asked a very, very simple question about reflexive, symmetric and transitive type of relations. First, we have to check whether it is reflexive or not. So, in this reflexive, let us understand M will have so many things, so many 1024 subsets will be there. It will start from 5, 1, 2 and so on up to 1024 numbers it will be there, including the whole set itself, right? Now, if you go to see, at one point it destroys the particular relation. If you say phi intersection phi is equal to phi, which does not satisfy this relation, it has to be non-empty, but you are getting an empty set here. All other things it satisfies probably, but this one it will not satisfy. So one example you get which says that it is not a reflexive relation. Yes, let's go for this whether it is symmetric or not. Let's see. Suppose you take a relation 1, 2 intersection 2, 3. Yes, it is non-empty set. We know it is non-empty set. It is not an empty set. Let us see whether it is 2, 3 intersection 1, 2. Obviously, it will be non-empty because reverse is also applicable, commutative. Yes, symmetric is like that only. No, reverse also the same thing. It has to be non-empty set. So there it satisfies. Whichever pair satisfies this relation has to satisfy this relation also. So it has to be symmetric. But there are two choices in symmetric. Let us see whether it is transitive. Now the relation could be transitive. Suppose we take 1, 2 intersection 2, 3. Yes, it is non-empty. You know that. Let's take another one. 2, 3 intersection 3, 4. That's also non-empty. You have no 3 is common. Now what about 1, 2 intersection 3, 4? See here it fails. Sorry, it is an empty set. Is equal to phi. It's an empty set. So here it fails. The relation fails. Right? So because it is not transitive, because it is not reflexive, it has to be symmetric only. Right? I'm sure you like my explanation. If you like my videos, keep watching more videos. I'll come with more and more videos of these solutions of this maths as well as physics PYQs. Okay, keep watching. Thanks for watching this. This is Mahesh Tolaskar saying bye-bye.